Hello, and welcome to my presentation today on having the right attitude, how attitude impacts trust repair in HRI. This was a paper I worked on with Professor Lionel P. Roberts, and both of us have the affiliations at the University of Michigan's School of Information, while Dr. Robert is a core faculty member at the Robotics Institute. So first off, why did we look at trust repair? Trust repair is important because, as some of you might know, robots are in a place where learning is becoming increasingly important. This is how they're able to deal with potentially novel tasks or adapt to different environments and preferences. One of the tricky things about learning, as any grad student will tell you, is it involves making a lot of mistakes. This means that robots will make mistakes, and likely more than once. For robots to be given the space to improve, however, they need to maintain humans' trust in them. They can't be abandoned before they're able to improve. One of the methods to maintain a level of trust while you're, for lack of a better word, being somewhat untrustworthy, making mistakes, learning, is to implement different forms of trust repairs. Trust repair can be defined as efforts undertaken by a trustee to restore trust following an actual or perceived trust violation. Apologies, denials, explanations, and promises are the four most popular approaches to this based on the human-human literature, and each have been looked at in the HRI literature as well. Apologies are expressions of remorse. Denials are a rejection of culpability or that a violation happened. Explanations are similar to justifications, but they provide reasons why something happened. So they're providing a context, something like that. Because of X, I messed up. And promises are assertions that convey positive intentions for the future. So at this point, you might be asking, do these repairs work in HRI? Do the same strategies of repairing trust in the human-human literature carry over? And unsurprisingly, in HRI, the literature is somewhat mixed. Sometimes these strategies work, sometimes they don't. In short, it's everyone's favorite phrase, it depends. But the next rational question based on it depends is, what does it depend on? Why are these studies producing different results? Well, as you may have gathered from the title of this talk, we think that it might be positive attitudes. The next thing you might be asking, though, is why do you think that? And that gets a little bit more complicated. We know that positive attitudes influence humans' expectations of robots. If you have a higher positive attitude, you'll have higher expectations of the robot. If you got a less positive attitude, you'll have lower expectations. The thing about expectations, though, is that they are not always met. And indeed, there are times when your expectations will be shattered. When this happens, we are uncomfortable. Psychological theory has a name for this. It's called dissonance. Trust violations in particular can lead to this discomfort, i.e. this dissonance that we feel. Now, the natural thing for humans to do when they are uncomfortable is to make the uncomfortable situation go away. In theory, this comes about in two ways as far as dissonance is concerned. We either analyze and change our expectations, which is a little harder, or we justify and reinforce why our expectations are right. So what's all this got to do with trust repairs? Well, basically different repair strategies may be tailored to one of these different methods of removing dissonance more so than another. In this paper, we propose that apologies and denials seem to encourage changing one's behavior, while promises and explanations seem to reinforce existing positive attitudes. So when your expectations are violated, you'll adopt one of four different repair strategies, but these can be grouped mechanically based on cognitive dissonance theory into two sort of camps: encouraging change or reinforcing existing beliefs. This leads us to our first hypothesis, which is that human-robot trust repair strategies that seek to reduce dissonance via justification and reinforcement are more effective for individuals who have greater positive attitudes than trust repair strategies that do not. While it might be easy just to leave it there, it's important to consider that when a robot messes up one time, it's going to mess up again. It's realistic to expect that repeat errors are going to occur. And in the human-human literature, we've seen that these can broadly decrease the effectiveness of trust repairs. Fool me once, fool me twice, that old saying. So in some ways, we expect that attitude won't play an important role if repeat violations happen. This leads us to our second hypothesis, which is that human robot trust repair strategies are less effective over repeated trust violations, independent of positive attitude. Okay, great. We got hypotheses, we got a general theoretical framework. Let's talk about what we're going to do to test this. First off, we created a scenario where we have a task where a human collaborates with a robot. You can see this environment here. Errors occurred at 3 equidistant time points, and the study was conducted online. So we had a lot of different participants. We have a task. The robot collaborates with the human. Awesome. We've got a reasonable task, and I'm not going to detail it here just in the interest of time, but we've got what we need. So with this task inside this environment, we were interested in manipulating things, as you do in experiments. In particular, what we manipulated was the trust repair strategy that was given. This was either apologies, denials, explanations, or promise. We also included 2 conditions used for the sake of manipulation checks. This was a no error condition where the robot performed perfectly, and a no repair condition where the robot was silent after violations. We also measured positive attitude as part of a pretest questionnaire. This allows us to incorporate it into our analysis and look at the relationship that positive attitude might have on the efficacy of these different strategies. This leads us to our dependent variable. And the primary dependent variable we were interested here was trust decrease, or how bad violations were considering someone's trust. Trust repair strategies seek to decrease the decrease. So it's a little confusing, but basically the less bad it was, the more effective the trust repair strategy was. So we got all this methodological stuff. We got a good study design. Let's see what we got. What were the results? First thing you want to do when you're in this situation is make sure that what you manipulated actually worked. Given that trust was significantly lower in the no repair condition, this is where the robot was silent, than in the perfect condition, where the robot didn't make any mistakes, we realized that our violations decreased trust effectively. In short, our manipulation check passed, and we're good to go. Trust was decreased. With that out of the way, we wanted to determine what kind of interaction effect might be there between different trust repair strategies and attitude over these repeated measures. So we ran a repeated measures and COVA. That's an analysis of covariance. And we did see a significant effect. We saw that individual attitudes appeared to significantly moderate the effectiveness of human-robot trust repair overall. But we also wanted to look at this at a higher fidelity. So we ran some post-hoc tests. And in these post-hoc tests, things got a little interesting. In particular, we saw that the impact of positive attitude was only significant after the second violation. And we saw that the impact of positive attitude was different depending on the repair strategies that were used. In particular, this is most pronounced when you compare the promises, the little blue dotted line there, to denials, the green line. Completely opposite directions. And so this was something that is insightful and provides some new perspectives on how positive attitude might impact the relationship or the general efficacy of trust repairs. So from this study, we can gather a few different insights that are contributions to the field. First, the influence of individual differences was not uniform across repair strategies. Therefore, it's likely that attitude impacts some strategies and might not impact others. Studies that don't incorporate positive attitude, though, may not be seeing entirely accurate results, as this variable could be influencing or producing non-significant or overwhelmingly significant results. In a similar way, we saw that trust repair was not significantly influenced by strategies after the first error, but was after the second. So it's really important that we incorporate multiple violations into future work, because it seems that only looking at trust repairs after one violation, i.e. this first time point, you only get part of a bigger picture. Our third takeaway relates to cognitive dissonance. Cognitive dissonance could be a useful tool, theoretically, for explaining trust repair and categorizing the different types of repair strategies that exist. Currently, no framework that incorporates this is there, but future studies may wish to consider cognitive dissonance when building models or theories of trust repair. Finally, attitudes towards robots were found to influence trust repair in HRI. Therefore, mixed results in HRI may be due to positive attitudes or even other individual differences that exist. More research is needed along these lines. Finally, I'd just like to say thank you for coming to talk and for being at HRI. Without further ado, we can see you at the session and we'll have a live discussion of these results.